The end of the world has captivated humanity for millennia. Ancient prophecies, disaster movies, and whispered anxieties all revolve around this singular event. From the Mayan calendar to Nostradamus, predictions of doom have always intrigued us. But what does science have to say about the ultimate fate of our planet, our sun, and indeed our universe? Are we truly on the brink of an apocalypse, or is there more to the story? The laws of physics and the observations of astronomers provide us with some compelling clues. Through the lens of science, we can explore the intricate workings of the cosmos. These clues paint a picture of a universe that is dynamic, ever-changing, and ultimately subject to forces that dwarf our everyday experiences. From the birth of stars to the collision of galaxies, the universe is in constant motion. The good news is that the end, at least as we understand it, is not imminent. Our planet still has billions of years before the sun exhausts its fuel. So let's embark on a journey to the end of time, exploring the scientific theories that describe how our universe might meet its ultimate fate. From the Big Bang to the potential Big Freeze or Big Crunch, the possibilities are as vast as the cosmos itself. One of the leading theories about the end of the universe is known as the Big Chill, or heat death. This theory suggests a slow, drawn-out end where the universe continues to expand indefinitely. As the universe expands, matter becomes more and more dispersed. Eventually, stars will exhaust their nuclear fuel and die out, leaving behind remnants like white dwarfs, neutron stars, and black holes. These remnants, too, will eventually evaporate over unimaginable timescales, leaving the universe a cold, dark, and desolate place. In this scenario, the universe doesn't end with a bang, but with a whimper. While the Big Chill suggests a slow end, the Big Rip offers a far more dramatic scenario. This theory hinges on dark energy, a mysterious force accelerating the expansion of the universe. If dark energy continues to increase, it could eventually overcome the fundamental forces holding matter together. Galaxies, stars, planets, and even atoms themselves could be torn apart. The Big Rip is a chaotic and cataclysmic end, a cosmic unraveling that leaves nothing behind. Section 4. Back to the beginning, the Big Crunch. This theory presents a fascinating and dramatic end to our universe. In contrast to the ever-expanding fate proposed by the Big Chill and the Big Rip, which suggest a universe that continues to grow colder and more isolated, the Big Crunch suggests a universe destined to collapse back in on itself, reversing the expansion. As gravity pulls everything back together with an immense force, the universe will begin to contract, shrinking in size and scale. Galaxies will rush towards each other at incredible speeds, and the temperature of the cosmos will increase dramatically, reaching unimaginable levels. Ultimately, everything would collapse into a single, infinitely dense point, known as a singularity, similar to the singularity from which the Big Bang is thought to have originated, marking a cyclical nature of the universe. This could potentially set the stage for a new Big Bang, a cosmic rebirth, and the birth of a new universe, starting the cycle of creation and destruction all over again.
Section 5, Cosmic Threats, Asteroids and Supervolcanoes. While the Big Chill, Big Rip, and Big Crunch describe cosmic endings on a grand scale, there are other, more localized threats that could spell disaster for life on Earth. Asteroid impacts, like the one that wiped out the dinosaurs 66 million years ago, pose a significant threat to our planet. Supervolcano eruptions can eject enormous amounts of ash and gases into the atmosphere, blocking out the sun, causing global cooling and devastating ecosystems worldwide. These events highlight the importance of scientific monitoring and preparedness to mitigate such risks and ensure the continued survival of our species.
Section 6. The Future of the End. The question of how the world will end has captivated humanity for centuries, sparking curiosity and wonder in the minds of philosophers, scientists, and dreamers alike. Thanks to the relentless pursuit of knowledge through science, we now have a better understanding of the potential scenarios that could unfold. From the slow, inevitable heat death of the Big Chill, where the universe gradually cools and fades away, to the violent and dramatic unraveling of the Big Rip, where the fabric of space-time itself is torn apart, and the cyclical nature of the Big Crunch, where the universe might collapse back into a singularity only to be reborn again. These theories offer a glimpse into the vastness and complexity of our universe, each scenario more fascinating and mind-boggling than the last. While the ultimate fate of our universe remains uncertain, the quest for answers drives scientific exploration and discovery. Through the diligent work of researchers and the advancement of technology, we continue to unravel these cosmic mysteries piece by piece. By studying the cosmos, we gain a deeper appreciation for our place in the grand scheme of things, understanding the delicate balance that sustains life. This knowledge underscores the fragility of life on our planet, reminding us of the preciousness of our existence. For in the end, it is not just about how the world ends, but about how we choose to live our lives in the face of such profound mysteries. It is about the connections we make, the love we share, and the wisdom we gain. Ultimately, it is about what we learn about ourselves and the universe along the way, and how we use that knowledge to shape a better future for all.